some rules or properties that help us with integration. Now you notice I say of the definite integral. I'll explain the difference between that in a sec. So here's our basic rule that we saw yesterday. If we're going to integrate, much like we saw with the primitive function, we simply add 1 to the power over that new power. And we substitute in the top number minus the bottom number. Okay. The second one is basically saying you can factorize. Like an integration symbol is a grouping symbol, just like parentheses and all the same absolute value signs. It is a grouping symbol. But the only thing we have to watch out for, you can only factorize constants. So you can't take an x out of the integral sign. You can only factorize out constants. The third one is saying, well, if you've got a sum of things that you're going to integrate, you could break it up and integrate them one at a time. Or another way of putting it is if you've got several things added together, you could create one integral. So either way. So whether you add them together first, then integrate, or integrate them first, then add them, it doesn't matter the order that you do that in. Now, this one might look a little bit silly. C, by the way, would be some number in between A and B. And so what it's saying is if you want to find the integral from A to B, what you could do is find the integral from A to C, find the integral from C to B, and then add them together. Now, if you think of that in terms of area that we saw yesterday, so what it's really saying is if you've got one big area, you could break that up into 2 different areas. Might be because they're 2 different shapes or something like that. So you do something like that. This becomes useful when we start looking at curves above and below the axis and where we need to break the integral up. Now, this is saying the integral will be positive if the function is positive. So if the curve is completely above the x-axis, so the function is completely above 0 between A and B, where we're integrating, then the answer we will get will be positive. That's what that's saying. Whereas if it's below the x-axis, the answer will be negative. It'll come up with a negative number. If the gx is above the fx, then the value of the integral of fx will be less than the value of gx. And again, if you think of the picture, that makes sense, because if you're between 2, you're finding the area, then clearly the area of the curve above would have to be a bigger area than the curve below. That's all this one's really saying. You don't have to have the biggest number on top. Okay, people will often make that mistake that you always have to have the biggest number on top. Now, that's the standard way of doing it. But if you want to swap the values round, and we'll see some examples in the course of the next few days of why we would want to do that, then you can do it, but you need to multiply by -1. Because if you think about it, instead of going B minus A, you would go A minus B. So you'd end up with the negative of the answer. So that's why you need to multiply by a negative to get it back to the right answer. If you know the curve is an odd function, you can save yourself a bit of time using symmetry. Remember we said that the area of the x-axis will be positive and below the x-axis would be negative. So think of an odd function. There's the cubic over there is probably a classic example. If I was going from, say, -2 to +2, now the area would be the same below as it is above. But the area below is a negative, area above is a positive, so when I add them together, they'll cancel out. And so we'll get 0 as the answer. So if you notice it's an odd function, then you can save yourself a bit of time. You go, well, the answer is 0, because I'm using the symmetry of the curve there. Whereas an even function, we sometimes, instead of going from -A to A, we change it from 0 to A, probably because 0 is usually an easy number to substitute in, but we double it. Because of symmetry. This time, both sides of the y-axis would be above or below, so I only need to work out one side and then double it because of symmetry. And a reminder, if you're trying to work out whether a function is odd or even, and you've got like several functions multiplied together, odd times an odd will give you an even function, odd times an even will give you an odd function, even times an even will give you an even function. So same type of function multiplied together will become even, different types of functions will give you odd. And if you ever forget go back to the simplest case. Go to polynomials. We know all odd polynomials have odd powers. All even polynomials have even powers. So as odd, just think of y equals x, because that's power of 1. Even, think of x squared. So odd times odd would be x times x, which is x squared, gives me even. Odd times even, x times x squared would give me x cubed. Oh, that's odd. And then even times even, x squared times x squared gives me x to the 4. That would be even. So if you ever forget, just go back to a really simple case, and then you can work it out from that. All right, let's do some examples. 6x squared, and we're going to integrate from 1 to 2. I can factorize the 6 out and just integrate the x squared. And integrate the x squared, add 1 to the power over power, I get a third x cubed. I've then factorized the third out. 6 times the third is 2. Substitute in the 2, substitute in the 1, I get 14. The cube root of x. Well, we don't have a rule to sort out the cube root, so I've got to change the index form. Cube root of x was x to the power of 1/3. Now be careful here, add 1 to a third, we get 4/3. 4/3. So it'll become 3/4, because 1 over 4/3 is like saying take the reciprocal, so I get 3/4. X to the power of 4/3. Now I've converted that back to x times the cube root of x. X to the power of 4/3. 4/3 is 1 and a third. So it's x to the power of 1 times x to the power of a third. And the only reason I've done that is because look at the number I'm substituting in. 5. Cube root of 5 is not an exact number. Your calculator will just give you a decimal approximation. By putting this back in surd form, I can get the exact answer. So when I substitute in 5, I'll get 5 times the cube root of 5. And then substitute in 0, I get 0. So there's the exact answer, 15 times the cube root of 5 over 4. Hang on, we haven't talked about trig and how we integrate trig, so obviously there's something else happening here. Sine curve, odd or even? Okay, so if I'm going sine to the power of 5, odd times odd times odd times odd times odd, what do I end up with? Remember, if you're unsure, go back to a basic. If I said to you x times x times x times x times x, it would be x to the power of 5, which is odd. Odd function, but look, I've got symmetry. I'm going from -2 to 2. So I know the answer is just 0. Odd function to the power of 5 would equal that. Now, at this stage, that of course is an obvious answer. Once we start learning more techniques of integration, people can waste a lot of time with this question by going, oh, sine to the power of 5. Okay, I'll use my technique on how to integrate sine to the power of 5. It takes a little bit of time. And they'll still end up with 0, of course. But we'll have wasted a little bit of time. If they recognise it was an odd function, bang, get the answer of 0 straight away. Wow, I got 4 terms to do here, but I can save myself a bit of time. Again, symmetry, -1 to 1. And I've got polynomials there, and all polynomials, when I look at an individual term, is either odd or even. So I know all the odd ones, when I integrate, will be 0. So I'll just have the even ones. But also, we said with even functions, I can go twice from 0 to, in this case, 1. So the even ones, I'm left with 2x squared plus 1. So now I've only got 2 things to integrate instead of 4. Again, just saves a little bit of time. Add 1 to the power over the power. Then we sub in 1, sub in 0. There's my answer, 10/3. 11C.